Now we will start the driver development for GPU. So if you see that there is a function which is called that uh, GPU clock enable. Okay, so in this way you have to make this driver functions to enable the clock. So whenever user call, they only pass the whichever GPU clock you want to enable, or in this way you actually want to enable or disable the clock. That's corresponding flag. If pass enable, then it will enable, otherwise it will disable. In this GPU init functions also we have made this GPU init functions, and there is only one passing argument, that is GPU handle. Depend on the GPU handle, it will enable the clock, and then there is some first step is configure the mode of the GPU pin. So here I have initialized the mode. Then the second step is, so whatever mode, this normal GPU pin mode, interrupt mode, or then configure the GPU port selections. Then third point is, sorry, ext, enable the exti interrupt delivery using IMUT. So after configuring the GPU pin mode, then configure the GPU speeds, then select the pull up or pull down registers, and then output type. After that, fifth point is the, if you want to use this as a alternative function, then you have to use in this way. So in this way I have used the dnet read or write. So simply if you want to read, then only pass the GPI number, and the which pin number, corresponding pin number value will return the state of this pin. Read from this input pin, or you can also read a port, all the pin of this port status also return in this way, toggling, or you can also uh, write the data to set the pin, set or reset the pin. You can write the particular. In this way you have to generate the driver functions. So this all the function I have enabled. Now we'll move on to the next part, that is GPIO pin interrupt configuration. So interrupt is a very important part of our systems. So there are mm, most of the cases we use different type of GPIO interrupt to handle the different functionality. So how you will use a pin as a interrupt pin. So how to configure so that a pin act as a interrupt pin. Pin must be as a input. So first one is pin must be in input configuration. So for interrupt you have to configure the pin as a input. Then configure the edge trigger, which rising edge trigger, falling edge trigger, or rising and falling both. So rising edge triggers means whenever someone will, if the default state is low, then suppose the default state is low, once the press the switch, it's become high. So this is the rising state. Once it's released, it become also again low. So that is the rising state. and that is the falling state. Okay, so you can configure you want to rising state trigger or falling state trigger, or you can also get them both. So at the time the whenever you pin from low to high, that time also it's trigger the interrupt, and uh, high to low, that time also it's trigger the interrupts. So whatever your requirement, as per you configure the triggering, and enable interrupt delivery from peripheral to the processors, so that there is the NB controller, it will control and trigger the processor that you have to serve this corresponding interrupts. So it will also deliver the interrupt properly. Identify the IRQ number. So what is the IRQ number of this corresponding interrupt? You have to identify, and which processor accept the interrupt from that pin. So that's also you have to uh, identify that which processor actually accept this interrupt from this corresponding interrupt pin. Configure the IRQ priority. So you can also set the priority of this interrupt for identifying the IRQ number, and then enable the interrupt reception on this IRQ number. Until and unless you don't enable the interrupt reception, it will not accept the interrupt. That's why you have to enable the interrupt receptions, and then you have to implement the IRQ handler, where you whenever the IRQ or interrupt occur, then it's jump to the IRQ interrupt, and whatever action you want to perform on this IRQ handler, you have to write that task. Keep in mind that the task should be very less, otherwise it would be not efficient code to handle the interrupt. Now, how actually interrupt manage and interrupt accept and process? We'll see that suppose STM32 pin interrupt delivered to the processor. How to deliver the from GPIO to the processor sections interrupt. So from the GPIO, it's there is the EXTI block, external trigger block. Basically, sorry. So EXTI block does the edge detection. So it will basically detect the which is detect rising edge or falling edge, which type of is triggered occur, that's detected by this EXTI, and enable or disable interrupt delivery to the processor. So by enabling or disabling, it's decided that it will deliver the interrupt to processor or not. So that thing is decided in this EXTI block. So every pin is basically connected to a particular EXTI block. If you go into data sheet, you can easily see that there is the interrupt section in EXTI interrupt control EXTI. Okay, if you go, then you will see that this is the EXTI block diagram, and there are total 23 lines. So there is a peripheral interrupt. There is multiple register, that is pending request register, interrupt marks register, software interrupt event, and rising and falling, that is basically the edge detection circuits, and the input come in these sides, and based on this register settings, it will uh, send the trigger to the NB controller. Okay, so how basically they are connected. So if you see here that EXTI 0 line is responsible for all the zero pin of every port, PA0, PB0. So at a time only one GPI will able to trigger this lines. So all the peripheral zero pin are connected with the EXTI line 0. Similarly, PA1 will connected to the, so that is the mux register connected at the single trigger line. So at a time, if suppose you are using PC1, then at a time only PC1 will trigger the interrupt and that trigger go to the NBIC setting. Okay, so that is basically there is this EXTI line connected to the NBIC controller, and NBIC controller decided that the IRQ are configured or not, and there is the special register which decided also the priority, and depend on that it will send the corresponding interrupt to processor for processing the interrupt. Okay, so NBIC will decided that it will send to processor right now, or there is any higher priority task we have to send sharp first, then it will deliver the interrupt. So there are different registers basically for configuring the EXTI interrupt. So that's the system configuration external interrupt configuration register 1. So there, so based on this register configuration, it still decided that the which EXTI which pin is uh, or interrupt configuration is done. So there is the for EXTI 0 there are 4 bits is for EXTI 0, and depend on this bit configuration, if someone is writing that 00, then PA0 will be selected as the EXTI 0 line. If someone use 001, right, then the PB0 will act as a EXTI delivering EXTI 0 line. Okay, in this way triggers or which pin is acting as a EXTI interrupt, that is selected by this uh, register configuration. And there is also the another register 2, EXTI 2, that is for, in this way there are in the above we have seen that EXTI 0 to EXTI 4, now EXTI 3, EXTI 0 to EXTI 3, then EXTI 4 to EXTI 7, then we will see that EXTI 12 to EXTI 15. So that's are responsible for every port register port of this GPR pin. So corresponding EXTI and corresponding GPR ports pins are enabled. Now that is very important, that interrupt set enable registers. So when you want to use the interrupt, then you have to set this NVIX interrupt set enable registers. So there is IRQ number 0 to IRQ number 13. So there are multiple IRQ, and corresponding IRQ you have to enable whichever IRQ interrupt corresponding to the IRQ number. That IRQ number you have to enable. If it is at 0, then no effect. If you use 1, then interrupt will enable. So depend on the interrupt number. There are multiple in big interrupt setting registers. Okay, so there is, I think, 95 register, 95 IRQ numbers. So that's registers are responsible for enabling. Similarly, if you want to kill interrupt clear, then you have to disable the. If you want to disable the interrupt, then you have to uh, mm, you have to write one here. There is another clear enable registers. When you write one, then it will disable the interrupt. Okay, if the value is 0, then no effect, but if you write 1 here, then it will disable the corresponding interrupt. Similarly, there is the input priority register. So interrupt priority register. So uh, which IRQ you want to give, what priority and sub priority, that is decided in these registers. So there are basically every IRQ priority, their 4 bits are for priority and another 4 bit for sub priority. So their total 8 bits are used for this purpose. So for IRQ 0, so 0 to 15, basically the 4 bit, that means maximum value become 15. So 0 to 15 is the priority. 0 is 0 is the highest priority and 15 is the lowest priority. Okay, and again you can divide it another sub priority. There is also the 0 to 15 also in sub priority. Okay, so that's why there 8 bits are taken for this priority selections of every IRQ. Now we'll do some exercise. Write a program to toggle the LED on board with some delay. Case 1, use push-pull configuration for the output pin, and case 2, use open-end configuration for. So I have already discussed about what is push-pull configuration, open-end configuration. So during the output setup, first case you will use push-pull configuration, then second open-end configuration. Okay, and the toggle the LED. So that is the task. Okay, complete it, and thank you. If you have any doubt, you can